Today my subject of demonstration is DC generator. Let us start with its comprehensive definition. What is a DC generator? A DC generator is an electrical machine whose main function is to convert mechanical energy into electricity. Or, a DC generator is the type of electrical generator that converts mechanical energy into direct current electricity. What is working principle of a DC generator? A DC generator operates on the principle of Faraday's laws of electromagnetic induction, which state that whenever a conductor is placed in a fluctuating magnetic field, an EMF is induced in the conductor. If the conductor is guided with a closed path, the current will get induced. Now formula to calculate EMF of DC generator is shown, where Eg equals generated EMF across any parallel path. P equals total number of poles in the field. N equals rotational speed of armature, RPM. Z equals total number of armature conductors in the field. Phi equals magnetic flux produced per pole. A equals number of parallel paths in the armature. Main parts of DC generator are stator, rotor, armature windings, poles, yoke, pole shoe, commutator, brushes. Now let us discuss them shortly to understand. What is stator and its function? The main function of the stator is to provide magnetic fields where the coil spins. A stator includes two magnets with opposite polarities facing each other. These magnets are located to fit in the region of the rotor. Next is rotor explained. A rotor in a DC machine includes slotted iron laminations with slots that are stacked to shape a cylindrical armature core. The function of the lamination is to decrease the loss caused due to eddy current. Armature windings. They are in a closed circuit form. They are connected in series to parallel to enhance the produced current sum. Poles play a vital role in production of electricity because its value depends on number of poles. Other function of a pole is to hold the field windings. These windings are wound on poles and are either connected in series or parallel by the armature windings. Next is yoke. It is the external structure of the DC generator, and made of either cast iron or steel, which provides the necessary mechanical power for carrying the magnetic flux given through the poles. The pole shoe is mainly utilized for spreading the magnetic flux to prevent the field coil from falling. A commutator works like a rectifier that changes AC voltage to DC voltage within the armature winding. It is designed with a copper segment, and each copper segment is protected from the other with the help of mica sheets. It is located on the shaft of the machine. Brushes are important because these can assure the electrical connections between the commutator as well as the exterior load circuit. There are some losses in DC generator because the input power is not fully transformed into the output power. These losses are: copper loss occurred due to the resistance in the winding. Core losses or iron losses occur when the armature rotates in the magnetic field. And the mechanical losses occur because of friction between the parts of the generator. Mainly DC generator is of separately exited and self-exited type. Further self-exited type is divided into series, shunt, and compound wound generator. In a separately excited type of generator, field coils are energized from an independent exterior DC.
Separately excited DC generators are used in mine hoists and steel mill, for paper-making machines and in diesel-electric locomotives.
In a self-excited type of DC generator, the field coils are energized from the generated current within the generator. These types of generators can further be classified into series of wounds, shunt wound, compound wound. In series wounds, the field winding of a DC generator is connected in series with the armature. These are used in series lighting and in series boosters. In shunt wound, field winding of a generator is connected in parallel with the generator armature. With field regulators, these are used for light and power supply purposes, and for charging batteries they can be made to give constant output voltage. Compound wound DC generator have both series field windings and shunt field windings. These generators combine the characteristics of series and shunt generators. Short shunt wound and long shunt wound are two types of compound wound DC generator. If the shunt field is connected in parallel with the armature alone, then the machine is called the short compound generator. In a long shunt wound generator, the shunt field winding is parallel with both armature and series field winding. When the series field supports the shunt field, the generator is known as a commutatively compound wound. If the series field opposes the shunt field, the generator is known as a differentially compound wound. From compound wound DC generators, cumulative compound are used for lighting and power services, while differential compound wound DC generators are used as an arc welding generator and a constant current generator. Main applications of DC generators are: the separately excited type of DC generators is used for power and lighting purposes. The series DC generator is used in arc lamps for lighting, stable current generator, and booster. DC generators are used to reimburse the voltage drop within feeders. DC generators are used to provide a power supply for hostels, lodges, and offices. Thanks for watching. Hope this video will help you understand DC generator. Never forget to like, share, and comment video and subscribe this channel.